Now we will see the superposition theorem. Before that, we are considering the statement, taking the statement. In a linear network containing more than one source of EMF, that means there is a number of EMF or a current source also. The resultant current in any branch in the algebraic sum of the currents is the algebraic sum of the current. So simply by considering the EMF or taking it by separately, we are finding the different currents flowing through the branch, and we are finally adding it the currents. That means if you are considering if there is a 3 EMF sources is given, then we are considering the only one voltage source at a time and finding the current through a branch and replacing the other sources with their internal resistances. So firstly we will see the internal resistance of the voltage source is 0, because when there is a condition to replace the voltage source, we are replacing it with the short circuit, because the internal resistance of the voltage source is 0, and if there is a current source present, then we are replacing it with the open circuit, because the internal resistance of the current source is infinity. So simply we are replacing the current source with open circuit. Now we will see the first problem, which is based on the superposition theorem. Find the current through a 2 ohm resistor using the superposition theorem. That means we have to find the current through this 2 ohm resistance. By the definition of the superposition theorem, we are considering the different sources independently and finding the current through a 2 ohm resistance. And finally we are adding all the currents and we will get the current, actual current, which is flowing through the 2 ohm resistance. So first step is when the 40 volt source acting alone. That means we are considering only this 40 volt source. That means, and when we are considering only one source, we have to replace the other sources with their internal resistances. So simply suppose I am considering this 40 volt source. This is the 40 volt source in series with 5 ohm resistor. Then here it is the 20 volt is the voltage source, so internal resistance of the voltage source is 0, and we are replacing the voltage source with the short circuit. So simply again it is connected to 10 ohm resistor, then here it is 2 ohm resistor, then this 2 ohm resistor is connected to the 10 volt is the voltage source, and we have to replace it with their internal resistance, or we are replacing the voltage source with short circuit. Simply circuit will be like this after replacing the voltage sources, and we have to find the current through 2 ohm resistor. See here, the current suppose which is flowing from the 40 volt source, I am considering it is the total current, because in the circuit only one voltage source is present. So the total current which is flowing through the 40 volt, I am considering it as IT. So this current is coming to this node and distributed in two branches. Suppose we have to find the current through this 2 ohm resistor. I am considering that current as I dash, or one current is coming in 10 ohm resistor. That means we have to find the current through 2 ohm resistor. Here the current which is distributed in the two branches, so here we can use the current division rule. Before this lecture you have to see the lecture of the voltage and the current division rule, voltage division rule and the current division rule, which is the previous lecture, this lecture. Now see here, the total current which is coming to this node and distributed in the two branches, simply in 10 ohm resistor and the 2 ohm resistor. Now for applying the current division rule, we have to find the IT, which is the total current, and the total current will be find out by Ohm's law simply. So I is equal to V upon R. I is equal to V upon R. We are using this relation. Here we know the voltage, it is 40 volt, and we have to find the resistance. So simply here 2 ohm and the 10 ohm is in parallel, and which is in series with the 5 ohm resistor. So simply current, which is total current, is equal to the voltage V divided by R, and it is equal to 40 divided by, see here 2 and 10 is in parallel, so we are taking the parallel combination of 2 and 10, and which is in series with 5 ohm resistor, so plus 5, which is equal to, we get it is 6 ampere. That means total current which is flowing through the battery is 6 ampere. Now we are applying current division rule. Apply current division rule. Simply. So we have to find the current through 2 ohm resistor. The current division rule is when we are finding the current through one resistor, so we have to consider the parallel resistor which is in parallel with the 2 ohm. So simply the current through a 2 ohm resistor, I am considering it is I dash, which is equal to the parallel resistance to the 2 ohm is 10. So simply 10 divided by 10 plus 2 into the total current, it is IT, which is equal to 10 divided by 12 into 6, and I dash I am getting it is 5 ampere. And here we have to consider the directions of the current. See here, the current flowing through the 2 ohm resistor is to the right hand side, so I am giving the direction to this current which is right hand side. So here it is I dash. Now we have to find the current by considering the 20 volt source alone. That means when I am considering the 20 volt source alone, see here, this is the 5 ohm resistor which is connected to the 20 volt source. This is the 20 volt source, and the other sources we are replacing it with their internal resistances. So simply 40 volt source will be replaced by their short circuit. Then here it is the 10 ohm resistor, then this is the 2 ohm resistor as it is, and here again the 10 volt source we are replacing it with short circuit. Now in that circuit we have to also find the current through 2 ohm resistor, and the current through 2 ohm resistor I am considering it is I double dash. See here, the actual current which is flowing through the 20 volt is in this direction. Suppose this current I am considering it is IT, it is the total current. This current is coming to this node here and distributed in the 2 branches like this. So again we have to find here the total current which is flowing through the 20 volt source, and then we are applying the current division rule for finding the I double dash. So simply see here, the IT which is the total current equal to V divided by R, and it is equal to voltage source is 20 and the resistance here again 2 and the 10 in parallel, and this parallel combination will be in series with the 5 ohm resistor. So simply 2 parallel with 10 plus 5 which is equal to 3 ampere, and we have to consider the directions here. Through the 2 ohm resistor I double dash is flowing in the left hand side, so simply direction to the I double dash is towards left hand side. So sorry, this is the total current and we have to find the I double dash. Now here, see here, this is the total current which is coming here is the IT and distributed in the 2 branches like this. We have to find the current through 2 ohm resistor. When we are finding the current through this resistor, we have to consider the resistor which is in the numerator is parallel resistor. So simply I double dash which is equal to the parallel resistor to the 2 ohm is 10. So simply 10 divided by 10 plus 2 into the total current, and it is equal to 10 divided by 12 into 3. So simply I double dash which we are getting is which is equal to 2.5, and direction of it just to the left hand side because the current flowing through the resistor is to the left hand side. So simply I double dash which we have find it out here, it is 2.5 and the direction to the left hand side. Now we have to consider the other voltage source which is the 10 volt source acting alone. So simply see here, now we are considering the 10 volt source which is acting alone. So simply this 40 volt source will be short circuited which is in series with the 5 ohm resistor. Again this 20 volt source short circuited, then this is the 10 ohm resistance, here it is the 2 ohm resistance, and here we are considering the 10 volt source alone. So this is the 10 volt source. Now see here, in this circuit we have to find the current through 2 ohm resistor. Here the total current which is flowing through the battery is in this direction, and this total current again flowing in a circuit and coming to the node which is IT. So simply the current which is flowing through the 2 ohm resistor is the total current. So here there is no need to apply the current division rule here. So simply we have to find the total current, which is I triple dash. So I am considering it is I triple dash and direction which is to the right hand side. So I triple dash, which is equal to, it is simply V divided by R, and it is equal to voltage is 10 and the resistance is again here 5, and the 10 is in parallel, and then it will be in series with the 2 ohm resistor. So simply 5 parallel with 10 plus 2 ohm, and which is equal to, we get it is 1.88 ampere in the direction to the right hand side. Now according to the superposition theorem, we are adding all these currents and finding the current through the 2 ohm resistance. That means current through 2 ohm is equal to I dash plus I double dash plus I triple dash. Now according to, by superposition theorem, current through 2 ohm, which is equal to I dash plus I double dash plus I triple dash, which is equal to I dash, which you have get, it is 5 ampere, and the direction of it is to the right hand side, direction to the right hand side, plus I double dash, which you have get, it is 2.5. So simply it is 2.5 in direction to the left hand side. Now the I3 or I triple dash, which you have get, it is 1.88 ampere in direction to the right hand side. So simply it is plus 1.88 in direction to the right hand side. Now we are adding the currents which is in the same direction, subtracting the current which is in the different direction. So simply 5 plus 1.88 minus 2.5, and we are giving the direction to the final current which is having the higher magnitude. So simply 5 plus 1.88 minus 2.5, which is equal to, we get 4.38 in the direction to the right hand side, because the higher current is 5 plus 1.88. So simply the current through the 2 ohm resistor is 4.38 ampere. This is the final answer.